have you watched any of the other videos? Have you seen what it takes to like pass the 16 or whatever? I watched the first. So yeah, so before you flip out too much about it, because it's really like you're not going to know how to do every problem. Like no matter how much we review, there will be problems that you don't know how to do it. Okay. So this was in 2008. What it took to get each of these scores. So 3 is considered passing. 31%, right? So if you're able to get, a third of the points, that's passing. Even getting a 5, which is considered perfect, it's only 60%. I think last year there was like 1 or 2 people that got like all 180 points. It's just not, it doesn't happen. Like, it's really hard to do. I don't know that I could get all 180 points when I was taking one. So I know that, that's what's always hard for y'all. Y'all are used to being able to do every problem on everything you're ever given and getting hundreds on everything. And so when you can't do every problem, you start to feel like discouraged. But don't. Like, it's okay. It'll come. Once I show you some of it, you'll go, oh yeah. You can. I think No West bought one. Some of the problems though that she's shown me, or that she's asked me questions about, are way harder than that because she'll be asked. But I probably wouldn't do that. I probably do it totally. I have some, and you're open for it if you want. It's called Calculus Success in 20 Minutes a Day, and I think it's really good because it doesn't get to, it just goes over like the basics. And then I think the Complete Idiot's Guide to Calculus is really good. He's kind of funny, and I think he does a really good job of explaining stuff. Would that make sense for you? Would that make sense over in ways and stuff? If you wanted to borrow one of these. Yeah, that's a really good one. Okay. You can take that one. And he has like, the end of each section, there's like a little practice problem that you can do to see if you get it. Yeah. That one's got good stuff in it too. And both of those have the answers to whatever practice problems are in them. So I doubt y'all will have very much time, but maybe on the airplane or whatever while you're waiting in the airport. We're getting back to 100% at 2 a.m. So that's like our day is off. But it's really fun.
The thing is, I'm looking to buy one, but I feel really good about that one.
You do?
I've always known the answers, and I've never gotten below 90 on any test or anything, and I've always understood it.
Yeah.
Yeah,
the calculus test is one of the hardest ones.
Thought it through logically.
Yeah.
And how it all fits together, and
I know, it's just like all these rules you have to remember. Okay, so let's look at these. So 21. Functions w, x, and y are differentiable with respect to time and are related by this equation. X is decreasing at a constant rate of 1 unit per minute. So that is what we call dx dt. That is the change in x with respect to time. And it's negative 1 unit per minute. Y is increasing 4 units per minute, so that's the change in y with respect to time. And they want to know what rate is w changing with respect to time. And x is 6 and y is 20. So what we're going to do is we're going to take this equation and take the derivative with respect to time. This is like our related rate problem that we did. So the derivative of w would just be 1 dw dt. And then for x squared y, we have to do the product rule. That's product. So we have to do the derivative of y would be 1 dy dt plus last d first. The derivative of x squared would be 2x dx dt. So we're trying to find WDT, so we should be able to plug in for everything else.
So we have to do the chain rule.
We have to do the product rule, yeah.
What's the function?
First be last, plus last be first. So if you plug in after you do the product rule, right, so x squared times the derivative of y, which would be 1 dy dt, plus y times the derivative of x squared, which would be 2x x dt. Then they told you x was 6, dy dt was 4, y was 20, x was 6, and dx dt was negative 1. So 36 times 4, 144. And this would be 20, 40, 240, minus 240. Negative 96, I think. Probably my that freshman instructor, that's a lot of work for 1.2 points. Each right answer on the multiple choice is 1.2 points. Alright. Let f be the function defined by, I'm going to give you the function, on which of the following intervals is the graph of f both decreasing and concave up. So we're looking for where the first derivative is negative and the second derivative is positive. Right. Decreasing is wherever the first derivative is negative, concave up is wherever the second derivative is positive. So the first derivative would be 6x squared minus 6x minus 12. The second derivative would be 12x minus 6. Alright, so I'm going to factor this so I can figure out where this is 0. So I'm going to factor 6 out first, since those will all divide by 6. And then two numbers that multiply giving negative 2 and adding a negative 1. Negative 2 and 1. So 2 and negative 1. Alright, so I'm going to plug into this derivative to see where my derivative is negative. So positive 6, negative 4, negative 1. This would be positive. 0 would give me positive 6, negative 2, positive 1. That would be negative. Would give me positive 6, positive 1, positive 4. So between negative 1 and 2 is decreasing. And then we do the same thing with the second derivative to figure out where it's concave up. So we would figure out where this is equal to 0. We're going to get 1/2. And we're going to plug into the second derivative. Plug in 0, you get positive 6, and if you plug in 1, I plug in 0, I get negative, sorry, I get negative 6. If I plug in 1, I get positive. So it's concave up from 1/2 on. Right. We're going to kind of combine these two, like where they would overlap. So they would overlap from 1/2 to 2. Right. Use the furthest right beginning and the furthest left end point. Right. So they overlap between 1/2 and 2. They don't start overlapping until 1/2, and they stop overlapping at 2. That's another one. It's frustrating. That's a lot of work for that answer. We did get into the next couple of problems that are less time. So you have about 2 minutes of problem in this section, so those I think would take longer than 2 minutes. So these next two out. kind of make sense too? No.
I got it.
You got it?
Yeah.
Alright. Is the function defined above f prime of negative 1 is what? Alright, so what is it? Negative 1 is the place where this piecewise function changes its rules. So what you're going to do is you're going to take the derivative of, so the derivative of the first piece would be 3, and x is less than negative 1. And the derivative of the second piece is negative 2x, when x is greater than or equal to negative 1. So with the piecewise function, you've got to plug to both pieces. And if they match, that's the derivative. If they don't, then the derivative doesn't exist. So if I plug negative 1 into the first piece, I just get 3. Because the derivative of the first piece is a constant. If I plug negative 1 into the second piece, I get 2. So they're not the same. So the limit doesn't exist. It's just like whenever we're trying to figure out if the piecewise function is continuous, we have to plug that number into both pieces to see if they match. Well, if you want to know if the derivative exists for a piecewise function, you have to plug this number into the derivative of both pieces and they have to match. Does that make sense a little bit? Take the derivative of each piece and then plug that number in. And that's the limit. But if they're not the same, it doesn't exist. The number that you get. Like if these had both been 3, the limit would be 3. Or if they've both been 2, it would be 2. Alright, number 24. Anytime they ask about a horizontal asymptote, you should think Vogel-Botner-Weak species. It's the same thing as a limit of infinity. This is the same thing as a limit of x equals infinity. With a limit of x equals negative infinity. Those all mean the same thing. Horizontal asymptote, limits as you approach infinity, they're all Vogel-Weak species.
Okay, back to
Sorry. Yes.
So if they're not the same, you don't do this
No limit
thing
of
of like
limit.
changing over it. Okay, we'll just not do it.
So this one, if you think about it, if you were to multiply these out, on the top, the biggest power of x would be negative 12x squared, and on the bottom it would be 4x squared. Because really all we care about is the highest power of x on the bottom, that's what you compare. So this would be if exponents are the same, divide coefficients. So we get negative 3. Alright, this is an that kind of makes sense? 25. Okay. I'm going to show you how to do this problem, but I've never seen a problem like this before. I'm hoping that they wouldn't put this on there. It took me a minute to figure this out. I had to check my answers to make sure I could get it. So, they give you an equation for y in terms of x, and an equation for u in terms of x, but then they ask you for dy du. So what I would do is I would take the derivative of each of these equations with respect to u, because that's what they're asking for, is the derivative with respect to u. So the derivative of y would be 1 dy du. The derivative of x squared would be 2x dx